liquefied petroleum gas or LPG dispensing areas, the classification according to the National Electrical Code, or NEC, typically defaults to Class 1, Division 2. This classification applies unless specific conditions exist, notably the presence of a pit or depression in the area. If a pit or depression is present, the classification may shift to Class 1, Division 1. The rationale behind this classification system stems from the inherent properties of LPG as a flammable gas. In the event of a leak or accidental release, LPG vapors, being heavier than air, tend to accumulate in low-lying areas such as pits or depressions. This accumulation can create an explosive atmosphere, increasing the risk of ignition and subsequent hazards. The 18-inch up and 20-foot out rule serves as a general guideline for delineating the extent of the Class 1, Division 2 area surrounding LPG dispensing equipment. This rule establishes a zone within which flammable vapors are likely to be present under normal operating conditions or during accidental releases. However, it is crucial to recognize that this rule is not absolute and may be subject to modification based on specific site conditions and engineering assessments. It's very important to consult the NEC directly when making decisions about electrical installations and hazardous locations. The NEC provides detailed requirements for electrical equipment and wiring in Class 1, Division 1 and Class 1, Division 2 areas, including specifications for explosion-proof enclosures, intrinsically safe circuits, and other safety measures. Failure to comply with these requirements can result in serious consequences, including fires, explosions, and personal injury. To elaborate on the significance of Class 1, Division 1 and Class 1, Division 2 classifications, it is essential to understand the specific hazards associated with each division. Class 1, Division 1 locations are defined as areas where ignitable concentrations of flammable gases, vapors, or liquids are present continuously, intermittently, or periodically under normal operating conditions. This classification applies to areas where there is a high probability of flammable substance being present, such as inside a storage tank or near a leaking valve. In contrast, Class 1, Division 2 locations are defined as areas where ignitable concentrations of flammable gases, vapors, or liquids are present only under abnormal conditions, such as during equipment failure or accidental release. This classification applies to areas where the probability of flammable substances being present is lower, but still significant. In the context of LPG dispensing areas, the presence of a pit or depression elevates the risk of flammable vapor accumulation, thus warranting a Class 1, Division 1 classification. The pit or depression acts as a natural collection point for heavier than air LPG vapors, creating a localized area where ignitable concentrations are likely to persist. Conversely, in the absence of a pit or depression, the risk of vapor accumulation is reduced, and the Class 1, Division 2 classification is generally considered appropriate. It is important to note that the specific requirements for electrical equipment and wiring in Class 1, Division 1 and Class 1, Division 2 areas differ significantly. Class 1, Division 1 locations require the use of explosion-proof equipment that is designed to contain any internal explosion without igniting the surrounding atmosphere. This equipment is typically heavy-duty and rigorously tested to ensure its integrity in hazardous environments. Class 1, Division 2 locations permit the use of less stringent equipment, such as purged and pressurized enclosures or intrinsically safe circuits, provided that these systems are designed to prevent ignition under abnormal conditions. In addition to the NEC, other relevant codes and standards may also apply to LPG dispensing areas, depending on the specific jurisdiction and application. These may include regulations from organizations such as the National Fire Protection Association, or NFPA, and the Occupational Safety and Health Administration, or OSHA. It is essential to consult all applicable codes and standards to ensure compliance and maintain a safe operating environment. Furthermore, proper ventilation is a critical factor in mitigating the risk of flammable vapor accumulation in LPG dispensing areas. Adequate ventilation can help to disperse any released vapors and prevent them from reaching ignitable concentrations. The design and implementation of ventilation systems should be based on sound engineering principles and in accordance with applicable codes and standards. Regular inspections and maintenance are also essential for ensuring the continued safety of LPG dispensing areas. Inspections should be conducted to identify any potential hazards, such as leaks, corrosion, or damaged equipment. Maintenance should be performed to address any identified issues and prevent them from escalating into more serious problems. In summary, the classification of LPG dispensing areas as Class 1, Division 1 or Class 1, Division 2 depends on the specific site conditions and the potential for flammable vapor accumulation. The presence of a pit or depression generally warrants a Class 1, Division 1 classification, while the absence of such features may allow for a Class 1, Division 2 classification. Compliance with the NEC and other applicable codes and standards is essential for ensuring the safety of electrical installations in these hazardous locations. Remember to consult the NEC directly and qualified professionals. The 18-inch and 20-foot rule is just a guideline. In addition to understanding the classification of LPG dispensing areas, it is also important to be aware of the specific requirements for electrical equipment and wiring in these locations. The NEC provides detailed guidance on the types of equipment that are permitted in Class 1, Division 1 and Class 1, Division 2 areas, as well as the installation methods that must be followed to ensure safety. For example, in Class 1, Division 1 locations, all electrical equipment must be explosion-proof and approved for use in hazardous locations. This means that the equipment must be designed to contain any internal explosion without igniting the surrounding atmosphere. Explosion-proof equipment is typically heavy-duty and rigorously tested to ensure its integrity in hazardous environments. In Class 1, Division 2 locations, the requirements for electrical equipment are less stringent, but still important. In these locations, equipment may be either explosion-proof or intrinsically safe. Intrinsically safe equipment is designed to operate at low voltage and current levels, so that it cannot produce enough energy to ignite a flammable atmosphere. In addition to the requirements for electrical equipment, the NEC also specifies the types of wiring methods that are permitted in Class 1, Division 1 and Class 1, Division 2 areas. In general, wiring must be installed in rigid metal conduit or other approved raceways to protect it from damage and prevent the escape of flammable vapors. The NEC also requires that all electrical connections in hazardous locations be properly sealed to prevent the ingress of flammable vapors. This is typically accomplished by using sealing fittings that are filled with a special compound that hardens to form a gas-tight seal. Proper grounding is also essential for ensuring the safety of electrical installations in LPG dispensing areas. The NEC requires that all electrical equipment and wiring be properly grounded to prevent the accumulation of static electricity and to provide a path for fault currents to flow back to the source. This helps to reduce the risk of electric shock and fire. In addition to the technical requirements for electrical equipment and wiring, it is also important to consider the human factors that can contribute to accidents in LPG dispensing areas. Proper training is essential for all personnel who work in these locations. Training should cover the hazards of flammable gases, the proper use of electrical equipment, and the procedures for responding to emergencies. Regular inspections and maintenance are also important for identifying and correcting any potential hazards. Inspections should be conducted by qualified personnel who are familiar with the requirements of the NEC and other applicable codes and standards. Maintenance should be performed on a regular basis to ensure that all equipment is in good working order and that any potential problems are addressed promptly. In conclusion, the safe operation of LPG dispensing areas requires a thorough understanding of the applicable codes and standards, as well as a commitment to proper training, inspection, and maintenance. By following these guidelines, it is possible to minimize the risk of accidents and ensure the safety of personnel and property. Let's delve deeper into the specific aspects of electrical installations within these classified zones. We'll explore explosion-proof enclosures, intrinsically safe systems, and other protective measures that are crucial for maintaining safety. Explosion-proof enclosures are designed to contain any internal explosion without igniting the surrounding atmosphere. These enclosures are typically made of heavy-duty materials such as cast iron or aluminum and are designed to withstand high pressures. The joints and seams of explosion-proof enclosures are carefully machined to ensure a tight fit and prevent the escape of flames or hot gases. Intrinsically safe systems, on the other hand, are designed to limit the amount of energy available in the electrical circuit to a level that is too low to ignite a flammable atmosphere. These systems typically use low voltage, low current circuits and are often used for instrumentation and control applications. Purged and pressurized enclosures are another method of protection that can be used in Class 1, Division 2 locations. These enclosures are designed to maintain a positive pressure of clean air or inert gas inside the enclosure, which prevents flammable vapors from entering. The purging and pressurization system must be carefully designed and maintained to ensure that the positive pressure is always maintained. In addition to these specific protection methods, there are also a number of general requirements for electrical installations in hazardous locations. These include the use of approved wiring methods, such as rigid metal conduit or cable with a gas-tight jacket, and the proper sealing of all conduit and cable entries. All electrical equipment must be properly grounded to prevent the accumulation of static electricity and to provide a path for fault currents to flow back to the source. Furthermore, it is essential to ensure that all electrical equipment is properly labeled and identified. The labeling should clearly indicate the equipment's suitability for use in a hazardous location, as well as the specific class and division for which it is approved. Regular inspections and maintenance are crucial for maintaining the integrity of electrical installations in hazardous locations. Inspections should be conducted by qualified personnel who are familiar with the requirements of the NEC and other applicable codes and standards. Maintenance should be performed on a regular basis to ensure that all equipment is in good working order and that any potential problems are addressed promptly. It's also important to emphasize the importance of proper training for all personnel who work in LPG dispensing areas. Training should cover the hazards of flammable gases, the proper use of electrical equipment, and the procedures for responding to emergencies. Personnel should also be trained on the proper methods for inspecting and maintaining electrical equipment in hazardous locations. By adhering to these guidelines and best practices, it is possible to create a safe and reliable electrical system in an LPG dispensing area. Remember that electrical safety is paramount in these hazardous environments, and any deviation from the established standards can have serious consequences.